Hi, everyone. I'm Andy Kwaczala, an assistant professor from Western New England University. Today, I'm going to talk to you about using the entrepreneurial mindset to master kinematics and human body motion in a biomechanics course. This is a project that students work on throughout the course of a 16-week semester. It's a design project where they develop a validation report and use motion analysis technologies to measure kinematics and kinetics in human movement applications. It's a hands-on learning approach to apply course material for biomechanics, as well as an exposure to design of experiments in biostatistics. It really helps to promote student engagement because they're measuring on their own bodies and they get really excited about the projects they work on. On the picture here, you can see someone analyzing a football throw, which one of our student athletes was doing in the hallway right outside of the lab, which they had a lot of fun doing. It also helps to introduce students to new skills in the business world by using their projects and then applying them to a market analysis report, as well as ways to pitch their scientific information to a non technical audience. We also promote curiosity by helping students use real world applications to learn course material. And ultimately, you can see the list of deliverables for the course here. The literature shows that problem based learning improves student outcomes. By allowing students to pick their own projects, it helps to promote curiosity and help them become more invested in the projects that they're working on. Entrepreneurially minded learning, design, and innovation all improve technical skills in the engineering classroom through building and testing, as well as data analysis and troubleshooting. By giving students the chance for iterative design and allowing revisions to scientific writing, we help to create a supportive environment. And this ultimately leads to students feeling comfortable to learn through failure. The entrepreneurial based learning in the undergraduate classroom are needed to promote business acumen. This helps to encourage curiosity. Students will make real connections to the work that they're doing in the engineering classroom and help to create value in the projects that they work on. Engineering students really do require training on the entrepreneurial mindset that are focused on the three C's. There is a need for project based learning modules that allow in depth exposure to both technical and business skills in their engineering disciplines. And this is what makes this a unique module is that we really try to go in depth with the exposure to these skill sets by working on this throughout the entire semester on a project related to biomechanics. These are the learning outcomes for the project. I want to emphasize that I'm using the three C's. Students develop curiosity by designing their own study and picking the project that they work on. They use motion analysis technologies and study the body in motion. They make connections to the course material by working in a positive and engaging interactive environment, and they make connections to both the scientific literature as they review what's happening in the real world for biomechanics, as well as their societal impact by looking at things like news articles. Finally, they make connections and create value by developing products that have been smartly executed by first looking at things like market size and the potential economic value of the product that they're investing their time in. Ultimately, by having high quality deliverables with both their technical and non technical writing and presentations that are given to a broad audience, we have the opportunity to engage students and provide marketable material that really highlight their successes while working on this project. The next two slides go into great detail about how my biomechanics course is set up. For those that aren't teaching biomechanics courses, this might not be as relevant to you. However, what I want you to take away from this is that I've stacked a lot of the core content that goes into my course in the first 4 to 5 weeks of the class. This allows students to see the gauntlet of material that they need to apply to their project, as well as the technology and the resources that are available in a laboratory setting in order for them to execute their own individual projects. By doing this, students are exposed to all of the material they need in order to be successful in their own designs. The central themes of my class are to expose students to biomechanical models, both their strengths and their weaknesses, as well as motion analysis technologies and all of the different types of applications, as well as new and innovative technologies that are available in the biomechanical field. I have a strong emphasis in design of experiments and statistics, as well as helping students work on their scientific writing and data representation. In the following few weeks, we start to develop some of the business skills related to their specific project. We talk about how to develop a business model. We look for opportunities to find funding in the field, both from an academic perspective through grants that they could write, as well as through sports organizations to promote the sports applications. We finally learned how to do an elevator pitch using an online e-module that was provided by University of New Haven. And the students are given ample time between week 9 and 14 for data collection. And this allows students chances to also practice their scientific writing and give opportunities for feedback, both through several iterations of their reports as well as one-on-one instruction of biostatistics and design of experiments in the laboratory setting. Following is a list of projects that have run during the course of the past 2 years of running this module. These projects range from clinical applications related to cerebral palsy and multiple sclerosis to sports applications such as pitching, running, football throws, soccer, and boxing. One of the things that I really emphasize in my own research and all of my student projects is giving students the chance for feedback and iterative design. So for this technical project, this really comes down to what does a high quality figure look like and how do I get my students to produce this high quality data? So we talk about what kind of format to use on that figure, how to catch or grab a viewer's attention, and then how to hold it. We also talk about biostatistics quite a lot and talk about the different types of tests that you can run, so how to annotate those statistics in a graph. And finally, we talk about how a figure has to be a standalone object that you might be reading on a computer screen. So it has to be accompanied by a high quality figure caption with lots of information that can fully detail what's happening within the figure. As we move into the business content, one of the things that's really critical is that it's important for the instructor to be able to model entrepreneurial behavior in all that they do within the classroom. So this was easier for me to do because it really touches home to my own research, which is to develop portable motion analysis technology. So I talk a lot in depth and from a personal perspective about my collaborations with my research partners, ways that I'm always looking for opportunities for investment from companies or maybe the opportunity to even start my own company, as well as places where I might be looking for funding in order to help support that technology. We talk about business ventures and opportunities for the biomechanics field in general, as well as an entire lecture on company evaluation. So I've used in the past Vicon as a publicly held company. As of December of 2019, they no longer are a publicly held company, so I'm going to have to find a new application. But that's one of the unique things about this field is that some of the technologies are so cutting edge and novel that it's constantly changing. So this is just another teaching opportunity for me to discuss in the future. And ultimately being comfortable and in touch with your students enough to be able to talk about personal failures and the opportunities to try again. Again, modeling that it's okay to fail and that we want our students to push themselves to fail so they have the chance to try once again. I also try to get my students into the labs to see innovative technologies as much as possible through industry tours and trips to our clinical sites. When teaching business skills in the engineering classroom, one of the things I found is it's really critical to create a high fidelity model for them to mimic. I've used the business plan that was provided by Connecticut Children's Medical Center, which is a collaborator in my research, to help provide that information to the students. This helps students understand how to go after their target market size, how to do a cost analysis of their technology, and to look into the reimbursement strategies, whether you want to go through an insurance reimbursement option or to do a pay-to-play model. So in the Connecticut Children's Medical Center's application, they've taken a motion analysis laboratory, which was set up for clinical applications such as gait analysis. And they've used this to try to create a opportunity for a pay-to-play model for people, that, for instance, that play golf or for pitching analysis to come in and have analyses done by high fidelity biomechanists and the laboratory services that are provided at a cost to be able to understand how their body is moving. In addition to these types of business skills, by creating a business plan and a market analysis report, students also have to do these elevator pitches that are presented to two very specific audiences, and they are given two chances for success. Those are evaluated by myself as well as their peers, and by getting feedback from their audience, they can improve their pitch and do better in the second chance to revise. Ultimately, this all comes down to providing students the opportunity to use scientific data to try to sell a product to a broad audience. I used a series of modules to test pre and post to see if the students improved on these entrepreneurial mindset skills. The three technical areas, so technical, entrepreneurial, and business acumen, all improved after the module was completed at the end of the semester, which I was really pleased to see. These were all specific and related to motion analysis. Finally, using the entrepreneurial mindset, I used a series of questions that were already created using the Keen entrepreneurial mindset um, evaluation technique. And in this, what I was hoping to see improve, because these were the focuses of my study or my work, was the students' ability to investigate the market, to create a preliminary business model, and then to be able to evaluate both the technical and economic feasibility of their design, and also look at some of the benefits by interacting with society. These were the three that improved the most, which so I was really happy to see that those increased so significantly. Similarly, I had no interest in this module in explaining to them anything about intellectual property, identifying supply chains, or even testing concepts quickly and actually communicating with customers to see how they thought of the module. So it was nice to see that these did not increase with this particular module that was being done. Part of the pre and post module that was run with the students was to get some student feedback on how the project went. When it came to the business acumen, I got a lot of positive feedback relating the project to the market analysis. So they really liked learning about something new, what a market analysis looked like, what stakeholders were, and how to create a mission plan. They also liked the opportunity to think about the business aspect of the biomedical engineering field, specifically related to biomechanics, and also participating in the build and the design of a business plan in an engineering application. When it came to the in-depth content of the course, they liked the fact that they had this project from start to finish and they synthesized this material with the course content. So it was helpful for them to execute the entire design of experiments all the way through to that technical report at the end and to be able to see the whole process play out in front of them. This final comment is the epitome of my success when it comes to the module. The student said, I was able to walk through the entire process from concept formulation to designing experiments, market analysis, data acquisition and analysis, and reporting. This was an invaluable experience full of learning opportunities vital for the job market. There's nothing more than I want to see my students succeed, especially when it comes to preparing them for the real world in biomedical engineering. Here are some lessons learned from running this module 2 years in a row. I found that rubrics and examples of work are really critical for helping students understand the deliverables that I'm asking for. They need structure and concrete deadlines in order to hold themselves accountable to the timelines of the course. In the first year of running the module, I was a little bit more laid back about the deadlines. And in the second year, it was much more successful because I held them accountable to those set deadlines set on the first day of the course. Providing technical feedback often and early is really important for their success. And ultimately, if you want students to be excited about what they're learning on, give them an opportunity to learn about themselves. So learn about their bodies in motion, learn about their bodies or something that's going on in their own lives, and give them a chance to make it even a little bit competitive. I found that those groups that were looking to see who could throw the farthest or run the fastest were the ones that were the most engaged in their project. Students will invest a lot more time when they see the value of the project that they're working on. So if they can actually identify that they could start a company with the work that they're producing, they're going to be a lot more invested in their final project. Finally, I think one of the key components to the student success is their opportunity to take multiple chances to try to do it the right way. When you set the bar high and you give them a lot of expectations in terms of what they need to produce, but you support them throughout the entire process of the work, you allow them the chance to really push themselves all the way to failure. And by giving them that second chance to make it right, it's not so daunting to them, and they are much more engaged with the material. Finally, what I've learned from running this module is undergraduates are capable of so much more than we think, and if we give them the chance, they will ultimately succeed. A quick note about COVID-19. I do not plan on running this module in the fall. Instead, I'm going to run a series of shorter, smaller modules throughout the semester, and this will be supported by an individualized sensor pack that we're giving all of our students. This is an Arduino platform that has Grove sensor technology that allows students to have an individualized kit where they can collect human performance data using accelerometers, optical encoders, and heart rate sensors. This will allow us to teach in a unique socially distanced environment. Here's a short list of citations with the full citation list found in the ASEE paper.